I think we're good to go, right? Okay. Hello, everyone. My name is Lalit, and welcome to Mystikcon 2021. And with me is my friend and co-presenter, Karan. We're here to deliver a small talk and presentation on creating a DevSecOps pipeline with open source tools. About us, Karan, would you like to go first?
Sure. Now you go first.
Okay, so I'm an application security guy at Zynga. Basically, Zynga is probably you might associate with Zynga Poker, Farmville, and CSR Racing. So these are the games that Zynga creates. I'm an OSCP and OSW certified guy. I've been part of Mystico since 2019, so it's been second year with the family and second stint at Mystikcon. I generally talk about application security, but I'm also into sci-fi gaming, soccer, and whosoever wishes to connect with me, I've given my LinkedIn profile here. And over to Karan.
Thank you. Yeah, hi, I'm Karan. I work at Offensive Security. I'm the, Vicefolk Security. I'm a offensive security consultant there. I'm OSCP, OSWE, and CDP certified. I usually work in web application security, mobile application security, and I work with businesses to implement their DevSecOps programs and, if they need any consultation in DevSecOps space. In my free time, I like to watch and play soccer, pool, and I love watching sci-fi stuff. I've given my Twitter handle, so if you would like to ask a question, reach out to me, please feel free to do so. Yep. Over to you.
Thanks, Karan. So the agenda for today's conference or today's talk is what exactly is DevSecOps, what everyone has a general idea about it, since DevSecOps has been around for some time now. We look at some buzzwords and other questions around it. Then we look at the maturity model through which we evaluate how an organization is doing when it comes to DevSecOps implementation. And then we look at the tools available for our disposal, the different CI systems. We also look at the benefits of DevSecOps over traditional application or product security models and modern DevOps solutions. And we also look at some of the best practices that also go hand in hand with the DevSecOps model once applied in an organization. And then, of course, we have a practical walkthrough of how the pipeline looks like when it's done properly. So we're going to use only the open source tools. We have no commercial tool. Of course, there's a plethora of commercial tools available, but for starters, for startups or budding organizations which want to implement DevSecOps and shift left, in their approach, I think open source is a nice and an easy venture to walk through and just to get their hands dirty on DevSecOps. Moving on to the next slide. So just the basics about DevSecOps. So DevSecOps is actually, according to IBM, of course, so short for Development, Security, and Operations, and that automates the integration of security at every phase in the software of the software development lifecycle, from the initial design through the integration, the testing, the development, and the software delivery portion. So that actually means that whatever stages of DevOps are there, you try to embed an element of security in the pipeline so that you not only strengthen the security posture, but also don't miss out on certain activities that are to be done. Now that it didn't upon the security professionals that we need to move on to DevSecOps. Karan, next slide, please. Yeah. So in the past, the security was also treated as an afterthought by a separate security team and was tested by a separate quality assurance team. And that was not thought from the earliest that we should perform tests from from the beginning, or we should implement testing at every phase of DevOps. That was done at the end of the life cycle. And sometimes security teams would not be aware of the products released, whether their security testing was done or not. So for everything, I should say, from let's say from developing the code or to pushing the application when it was done, and the security team, they were not really notified to perform a pen test when the application was required to be moved to production environment. And then when it was actually identified that, hey, we need to perform a security testing, that would be too late. And in case you want to perform a pen test and you find a bunch of medium or high or even critical level findings, and that is, of course, when we move on to the production phase of the application. And that means it's going to have a lot of overhead over the developers team. And they would first identify what exactly would be the root cause, and they would fix, and then they would check with the security team again, hey, if the security issue is fixed or not, we can move on to the production phase. And that would mean that there are a lot of man hours that would go into just fixing the security issues. Now, what could be done over here is that we could just make sure that we implement security at every phase, so that instead of spending a lot of man hours into fixing the highs and criticals of the security issues, we could just fix them at the earliest stage. By identifying that, hey, this is the vulnerable component that you need not to have in your application or the software or the piece of code that you're using, and then probably just get rid of it, or maybe update it, or maybe use the updated version of the code. And then moving ahead, you don't find those associated security issues. So software developers adopted agile and DevOps practices, aiming to reduce the software development cycles to weeks or even days, or in some cases to even minutes, now that the DevOps has grown so exponentially into the organizations. This traditional approach would really become primitive. And if you were actually to compare how the developers would work, this is a pictorial representation of an assembly line, how a car would be assembled. And how the security team would work is actually they will just carve the wheels out of stone. So that would just that would be manually, and so that would just take a lot of time, just to get the security part over. And over to my friend to explain down further about the buzzwords that are associated with DevSecOps.
Thanks, Audit. Yeah, so when we are talking about DevSecOps or DevSecOps practices, or when we're talking about implementing any DevSecOps program in any organizations, we come across these buzzwords, and what we will do, we'll just go through those buzzwords one by one. So first one that we hear quite a lot is SAST, whatever you want to call it. In nutshell, all this is white box pen testing or white box testing or source code review. So in this type of testing, which it stands for static application security testing, whether it's a tool or a person, they would get access to your source code, and then they would go through the vulnerabilities. And they would find, like, if the user input is being sanitized or not, and then based off that, the vulnerabilities would be found. So there are a number of commercial and open source tools available. A few examples that we provided here is one is probably cheaper open source alternative is SonarQube. Then you have Veracode, and then there are like millions other vendors that provide similar offerings in this particular space. The next buzzword that we hear quite a lot is dynamic application security testing. So the difference between DAST and SAST is, in DAST, you actually run the application, and then the application goes through or runs through a tool. Like, example being, say, Burp Suite, you want to run a kind of automated scan, and the application, the scan would be run against that application, and it will try to find vulnerabilities. Now, you could do authenticated scan and non-authenticated scan, but your application would have to run in DAST environment. So you have like different types of tooling available, and similarly you have open source alternatives as well. So example being Zap, which is the OWASP flagship product for this particular testing. Moving on, we have RASP, or what we call is as runtime application security protections. So think of it as, I usually give examples when it comes to RASP around mobile applications. So say, for example, you've got a mobile application and you've got runtime application security protection. Your mobile application could detect if it's attached to a debugger. So if it's attached to a debugger, it might not enable all of its features. So that way, if someone who is trying to reverse engineer your application wouldn't know which features are available. Or in some instances, what we have seen is when these sort of protections are available, your application would crash as soon as it will be attached to a debugger or an instrumentational tool like Frida. So these sort of protections can be put in place as well. Moving on, another type of testing which is now making a noise in DevSecOps space or just in security space in general is called interactive application security testing. So this type of testing kind of sits between SAST and DAST, but it sort of takes like all the pros from these two types of testings. So what interactive application security testing tries to do is your application will run, but they are sort of agents deployed on your application servers. So this type of testing is done within the application. So what they try to achieve with IAST is that your application will run in a dynamic mode, and then the agents that are running on your web application server would look at like which code is actually being executed in a given time, or when a user is interacting with this particular window, or when this particular function is being performed. So this is what IAST testing does. Again, it depends whether you want to implement this type of testing in your CI/CD pipeline, because given the nature of this type of testing, it could take a longer compared to SAST and DAST testing. The next one that we hear quite a lot is the software composition analysis. All it is scanning for dependencies, or vulnerability scanning your dependencies, your libraries, your plugins, anything that you're using as part of your code or part of your project or part of your application. So what this tries to do is this tries to find known vulnerabilities in your code base, or plugins or third-party libraries that you're using. And it actually could play an important role when you are deploying your application by actually running a proper software composition analysis scan against them, because if you could mitigate or find vulnerabilities beforehand, it makes it quite easier for you to probably deploy your product in the production environment, because you know that your libraries are up to date. The last bit is the infrastructure as a code, which we hear quite a lot. From traditional infrastructures, the way the traditional infrastructures used to be deployed, in infrastructure as a code, everything is managed through code. Your application, your infrastructure's configuration, the infrastructure deployment, and even destroying infrastructure through code. And it makes it so much easier to share that code among other team members with other teams as well. And every time you need something, you could just simply, like your regular CI/CD pipeline, you just call this code that's there, to spin up a new environment. You've got various examples and various tools available to do infrastructure as a code. The key players in this particular space is your AWS CloudFormation. You've got Ansible, you've got Chef, you've got SaltStack, and you've got Terraform. Moving on, over to you, Lalit.
I'm still getting used to Zoom now. I don't sometimes understand where exactly are the controls. But yeah, so all right. So now when the organizations decide to introduce elements of security in the pipeline, one of the stages that you would find is that security team introduces SaaS activities when the application is to be moved from build process. So Karan, would you move on to the next slide? Yes, so this is one of the pictorial representations and an actual representation of how, when you're trying to shift left from the traditional approach, and when you try to introduce DevSecOps as a practice in your existing application development pipeline. So this ensures that, if we have certain amounts of toll gates implemented, for instance, The build process should fail if the code review process yield has any critical or high severity issues. The build process does not occur before the application developer does not fix them. So this is what I explained about one stage. And if you move on to the next slide, Karan. Yes, so here you can see, apart from build process, you can always include multiple stages or quality toll gates to ensure that you're deploying a better application from security perspective. So for instance, when you look at the develop state, so you could always include some pre-commit hooks and some SDK plugins, like there's find bugs for Eclipse, which you can always include. That not only identifies whether you're performing, whether you're coding for, let's say, a Java application with regards to OWASP top 10 best practices or not. And then when we go towards the right hand side, we see, from CI/CD server, we see that there's SAS and SCA, which Karan explained as the DevSecOps buzzwords. And then we move ahead into the staging and QA environment. We see how other toll gates of security can be inculcated into the DevSecOps pipeline. So this is not just a rewiring the whole and reinventing the wheel. The stage, the DevOps stage stays as is. It's just we try to introduce some of the toll gates that are already perhaps present in the DevOps pipeline, which most of the times developers include in their own pipeline. So for instance, if the linting is not done properly, the stage would fail, and so the build would fail automatically. So these are some of the stages that we could introduce our security elements into it. And there's almost you could see here that almost every stage apart from build, there is always an element or a toll gate of security that can be introduced into the pipeline. Karan, would you like to bust some myths and questions around DevSecOps? I think that is the next section.
Sure.
Yeah.
Yeah, so I guess these are the things, or these are the questions. Well, there are way more questions, but we just try to compile some of them. Like, I mean, when you try to implement DevSecOps or you're trying to implement that program, it's just the perception or the thinking around DevSecOps. So these are the questions that pop up. The first one that always comes up is DevSecOps actually going to eliminate like all of the issues? Like, it's actually not practical, like whether you do DevSecOps or not, or whether you have like $1 million worth of a commercial tool, or you have like 100,000 tools available in your pipelines. It's not going to be possible to eliminate 100% of the issues. The reason being, because none of the tooling that's even commercial is available right now, which could actually eliminate different types of issues that that affect our web applications or mobile applications or whichever application we talk about. So I think the general idea of DevSecOps is to actually catch as much of low-hanging fruit as possible. So that those like low-hanging fruits wouldn't form like a high severity vulnerability later on in the in the stage of the or the life cycle of the application. So the whole idea behind DevSecOps is you try to include security as early as possible, and you try to catch as many issues as possible. And again, it does not guarantee that it's going to catch 100% of the issues. So yeah, I think that's probably one of the major questions that gets asked. The next thing is it going to be cost effective? An answer to that is it could vary, but I mean, from my side, or probably from Lalit's side, yes, it is cost effective. The reason being, you've got open source tooling available, right? And you could implement, or you could perhaps build anything that you could build pretty much the whole pipeline using the open source tooling. So you don't have to spend money buying the commercial tooling. The next question that gets asked is, is it going to keep up with the evolution of my product? Well, yes, because if you're still sticking to the agile development and the way you're releasing your products, or your releases to products, absolutely. Most of the tooling that's available, which is open source, it gets updated on regular intervals. So, for example, Zap is OWASP flagship product, so you know that it's going to keep on getting updates. And similarly, all other alternatives that are available for open source tooling, they are definitely there, and they would definitely support your product going forward as well. So other questions that get asked are more around, is it going to be compatible with my CI/CD pipeline, or we are using Jenkins, or we are using GitLab, or we are using Circle CI, or whichever CI/CD platform that you're using? Of course, yes, because the reason for that is because all these tooling is available in Docker, so you could just deploy a container and then you can just simply run a tool. You don't really have to rely on the underlying system that you're using. All you have to do is, as long as you can run a Docker, you could pretty much deploy these tools in your CI/CD environment. So that sort of takes away all the dependencies on a specific platform, and that's what makes life so much easier. And we will see those examples, down the line. Next thing is, will this model keep up with the adaptations or improvements in maturity? And yeah, I think we covered that previously. Yes, because what's going to happen is, first of all, by the time you get to implement these tools in your CI/CD pipelines, you would go through this journey of maturing yourself, maturing your whole security model, the security culture, and how you sort of perceive, shift left, that whole idea. So this has to, first of all, you have to go through those journeys to be able to then implement these tooling in your CI/CD pipelines. And as you grow, or as your application or the infrastructure evolves, you could then look at how you can tune these tools that you have implemented in your CI/CD pipelines as well. So yes, definitely, it would keep up with whatever you're trying to achieve with your products and with your pipelines. Next myth, or what we've heard, or from experience, what we observed is, most of the companies refrain from buying security tools since they're expensive and would want to invest money in a better place where the return of investments is justified. Exactly right, because they don't want to spend money where they can't really see any value, right? So and that's probably one of the myths. And I think the fact is, what we already talked about and we have covered, is that you could pretty much build your whole DevSecOps pipeline, or you can introduce these security tooling inside your CI/CD pipelines with a complete open source tooling, right? So that means you don't have to spend money. You just have to make sure that you've implemented those tools correctly, and those tools would do exactly the same thing that a commercial tooling would do. And then you can observe whether you actually need a commercial tooling, or whether the open source tools are doing a good enough job for you. And the next thing is, when you have the CI/CD pipeline operational, how quickly you pick up these issues is also far better than just doing a pen test end of the day, which may just be obsolete after 2 or 3 weeks, because you may have like 10 different releases happened since you've done that pen test, right? So that's what the whole idea behind DevSecOps is, and that's what the what the facts are. Over to you, Lalit.
Thanks, Karan. So there are some of the common myths and the questions that revolve around DevSecOps that has been addressed by Karan. So there are plenty of questions that obviously we would be welcome to answer them during this talk if anyone has them. But these are the frequently asked questions that we all most of the time we get from our fellow information security professionals, or our company peers or leaders who always expect from us as information security professionals that, if we introduce DevSecOps in our existing pipeline, what are the factors that we need to consider, the cost being one of them. So that is why we try to address these kind of questions first for everyone, so that, let's say, if they try to, or if they decide to implement these kind of principles in their own existing infrastructure or in their own pipeline, what exactly they need to answer. So there would be at least a certain consensus around the teams and the security professionals that, hey, we need to address these kind of problems like that. And so moving on to the next slide, we've got the DevSecOps maturity model. No, the previous one. Yeah. So let's assume that you decide to make a move towards shifting left to DevSecOps. You swayed the organization into moving towards the shift left approach. Everyone is on board the idea, and you start implementing the DevSecOps into your existing pipeline. And the next question comes that, hey, we are implementing this solution in our existing pipeline. And so how do we evaluate this stuff? How do we quantify how it is doing? Is it doing well? Is it doing not well according to the general consensus? Or is it, are we at par according to the organization? And obviously, one thing to wonder is, how do we evaluate the maturity of the DevSecOps pipeline that we implement? And so that is why we have this maturity model, which is known as the DevSecOps maturity model. And this was created by Timo Pagel, and this is actually a live project that has been maintained by OWASP. So Timo had the initial idea that, how do we evaluate around the whole DevSecOps pipeline? What could be the levels of maturity that would exist in the maturity model? And then it is backed by OWASP, because OWASP are the foundation pillar around the application security. So it is just a Google search away, and first thing you will notice is a spider chart with a lot of elements, as we've included in the slide, and you will see that there are a lot of elements, from building to deployment to logging to application tests. These are all practical stages of the DevSecOps pipeline, and henceforth are the stages of the maturity model itself. And under the guidance of this model, the appropriate principles and measures are implemented. People are guided to implement in order to counteract these attacks. So for instance, whether there's any kind of SAST activity that you want to perform, and you want to evaluate these kind of security issues at first, and now you've identified some of the low-hanging fruits, and you want to move ahead and find out some complex issues. So what exactly do you need to do once you've implemented an open source tool? So DevSecOps maturity model is something that you can check out always, and it includes all the stages and all the explanations as to, if you want to move on from level 1 to level 2, or from level 3 to level 4, what exactly do you need to perform? How do you plan to mature your existing model? And so the stages tell you how you want to get started, and if you already have, the general idea is that how you want to push forward and migrate to a better situation. And so there are 4 levels of maturity. The level 1 is always the basic understanding of security practices. So we're going to cover the first level here in our practical demo session. This level, the level 1, actually signifies that, for instance, if you're starting off, what are the basic stages that you want to cover in your DevSecOps pipeline? So for instance, you want to include SAST activities, you want to include TAST activities, you want to include the composition or not. So these are the basic ideas, whether you want to perform these activities or not. When you move on from level 1, there is adoption of basic security practices. So, which means that, okay, you've introduced some of the tools, and now you want to mature it and strengthen it further. So how do you want it? Do you want to train your developers into security? You want to have security champions. You want to have, one particular team defined for one particular state. So there are multiple things. Level 3 and level 4 are also are again some advanced layers around the DevSecOps maturity model. So I think what we are trying to cover here is how you want to start and where do you want to see yourself when you're implementing a DevSecOps pipeline into your organization. And so level 1 is something that we have tried to cover in our practical model. And this is something that we try to communicate what we have, with the audience that we have. And over to you, Karan. I think next up is the practical.
You can cover the different tooling, and then I can do the next slides. Yeah, if you want.
Oh yeah,
You want to
yeah.
cover it?
I think, yeah, I mean, let's just, mix and match whatever we feel comfortable with. So, the DevSecOps pipelines can be built on any CI tool available. We've got Jenkins. We already have shown you how we cover the SAST activities in the tradition, how you first of all implement. And so we had Jenkins in the diagram, and then, we had a SAST activity, whenever there was a quality tollgate failure. And so it would go back to the developer for correcting the issues. And then it would just, rinse and repeat of the existing process. So we've got Jenkins, we've got Circle CI, Travis CI. There's so many tools available. And just for the ease of the presentation, we went ahead and chose GitLab CI. Reason being that it is something that we are comfortable with, and
It was easier to
it's
set up.
fairly, yeah, it's fairly easy to set up on GitLab CI. Yeah. Karan, you wanna explain further?
Yeah, sure. Yeah.
Yeah.
Thank you. Thanks for that. Yeah. So as Lalit said, yeah. So for this presentation, we'll be using the GitLab CI. So we just move on. Before we actually jump into the practical, so let's just look at some of the DevSecOps practices. So as I talked, we talked about the Security Champions Initiative. I think before we implement this program, which is DevSecOps in any organization, it's really important that we have Security Champions Initiative. And those of you who don't know what Security Champions Initiative is, it's actually having security advocates sort of planted in different departments of your organization. And these are the people who are passionate about security, who want to learn about security. These could be developers, senior developers, architects, could be anyone who wants to learn more about security, and they're passionate about it, and they want to be your voice. So what you can do with the help of security champions, you would get more visibility into those teams. So you know what's happening in each department, right? So that's why the Security Champions Initiative is the core of DevSecOps. So before you even get to the practical side of things, adding tooling and whatnot, and even thinking about tooling, you have to, first of all, you need to change the culture of your organization, because that's how you would actually start to shift security to the left. I could spend like 2 hours just talking about security champions, but we've got so much other stuff to cover. So how long the tool should run for? So this is like another thing that you need to keep in mind. So when you implement any tool in your DevSecOps pipeline, or sorry, the CI/CD pipeline, you need to make sure that that tool doesn't run for more than 10 to 15 minutes. Like the 15 minutes is max. So whether you do DAST, SAST, or whichever type of testing that tool does, your tool should not hold the whole pipeline for more than 10 or 15 minutes, because the speed is the key. So keep that in mind. So what should be the output of the tools? So any tool that you implement, the output of those tools should be in a machine readable format. So the reason for that is, so when I say machine readable, that means it could be JSON, it could be XML type of output from these tools, because it makes it easier for perhaps your other tool to consume that file that's spit out by your tool. Example being, say, your tool spit out a JSON file, it's easier to probably import that into your vulnerability management system. If your tool is stitching out TXT files, the other tool probably wouldn't understand. So you have to make sure that the output of your tools needs to be in a machine readable format. So the next thing is like how to reduce your false positives. Now, this is really, really important, and this is a key here. This all going to depend on your experience. It's going to depend on the tooling. It's going to depend on how finely you're tuning your tools as well, right? So for example, if you're doing a static code analysis, it may find 50 vulnerabilities, like it may say there are 50 XSS, but there may not be any. So you need to make sure that you're tuning your tools right. So end of the day, you don't have to sit there and triage like 100 different tickets that are generated by your tool. So that's really, really important. And that's probably where some of the commercial tooling can shine. But then again, it's all cost benefit analysis type of thing that you have to do. How to manage vulnerabilities. So there are various toolings available to do vulnerability management. Again, since we're talking about open source here, you could perhaps kick off your vulnerability management with Defect Dojo. Again, that's a OWASP flagship project, so it has like support for so many different tools. So we will highly recommend that you would go ahead and start reading up on Defect Dojo, because rather than paying for a commercial tooling, just start off with open source. Now, this is what our pipeline is going to look like, and I'm just going to demonstrate that to you as well. We've got like 23 minutes, so I just want to rush as much as I can. So what you're seeing here is we've got 4 different stages in our pipeline. So we've got a build stage, we've got a test stage, we've got an integration stage, and we've got a deploy stage. You could have 10 different stages, that doesn't matter. You could have as many different stages as you like. And that would vary from organization to organization. So what we're trying to show you here is like what different type of tooling we have implemented at each stage. So the build stage here, we are just building the application to make sure like there is some sort of artifact there for us to do some sort of testing. So in the build stage, we are running a tool called Retire.js. So what this tool does, it's gonna run software composition analysis, and it's gonna find vulnerabilities regarding any outdated JavaScript libraries. So that's what this particular tool is going to do. The safety is another similar sort of tool that's going to find known vulnerabilities in Python dependencies. So anything that's available in requirements.txt, if any of those dependencies are vulnerable, it's going to spit out that output that, okay, these are the vulnerabilities that it found. And then we've got another stage, which is the test stage, and we've got a tool implemented Bandit. So Bandit is a tool that can do static code analysis for Python code base. So that's why the name of what we try to do is we try to give a little bit of a suffix here, so you could actually see what sort of the tooling it is. And then we've implemented TruffleHog. So what TruffleHog does is it detects all the secrets that you may have accidentally committed in your code repository. And then before these two things happen, the test job will run first, because it will make sure that the application sort of responds the way it's supposed to be. And then we've got another stage, and here we are just simply running an nmap scan, and then we are running another tool called SSLize. So this tool would do things like check the application for any outdated SSL protocols, if it's using, say, SSL version 3, or if that application is vulnerable to Heartbleed or something like that. This tool would pick it up, and this tool would also see if you're using TLS 1.0, 1.1, and then highlight those as well. And then here we're running ZAP for just a dynamic application security testing. And then the last, once all of this is done, and then we've got a deploy stage, and then we can deploy the application to the production environment only if we happy with the output that these tools have generated. Yeah, so I've already sort of talked about the tooling that we've implemented, so I'm not gonna go through these tools again, but as you can see, we've just talked about what these different toolings that we have implemented. So now let's move to actual demos. So let's pray to the demo gods quickly. And here we've set up, so this interface that you're seeing is GitLab. So we just simply created a private repo for us, and we created our own GitLab runner where all of these jobs would run. And what you're seeing here is we have deployed a vulnerable Python application, which is available for you to go on. It's available in GitHub, so you could just simply go and explore. That's the name of the application. So when you are working with GitLab CI, this is the file called gitlabci.yaml. This is the file that has everything that your GitLab would need to run your CI/CD pipeline, right? So here, I may zoom in a little bit so that may be a little bit easier on the eye. So here we have defined different stages that we want to run, as I demonstrated that I showed it to you previously. So we've got 4 stages. We've got build stage, we've got a test stage, we've got the integration stage, and we've got the deploy stage. And here we are defining each and every job, like what job would run under a particular stage. So for example, as Lalit was explaining, if you want to do a static code analysis, perhaps in a build stage, that job would take place, and then that job will create some sort of output, and then someone would have to look at that output or need to sign that off before your application is released, right? So similarly, you could have 10 different type of tooling implemented in a particular pipeline. So this what you're seeing here is one pipeline that we have built. And another thing that you probably want to keep in mind is probably when you are really new to your DevSecOps journey, or when you're talking about maturity level 1, you don't want to fail the builds. The reason for that is because as a security person, if you're implementing your security tooling and you start to if you start to fail the builds, it's going to create so much work for your development team or DevOps team, and it's going to create so much backlog. And for that, you don't want to fail the builds. So even if your tool finds something, you don't want to fail it. You just want to say, okay, you found something, we're happy with that, but move on to the next job. So that's what you want to achieve in your level 1 maturity. And as you grow and as you mature in your DevSecOps journey, you can then start to fail jobs because you know that your tooling is tuned, you know that it's not going to generate any false positive. So you have to keep that in mind as well, because when it comes to practicality, DevSecOps is like, it's because then you have to tell your managers why you are not releasing in production, and what's actually holding you back. So yeah, so as we were demonstrating, so here you can see we've got the build stage, and we are just simply building the application here. That's what the code what it's doing. And then similarly, we are just simply testing. Once the application is built, we're just testing the application, and then we start to implement our tooling. So here we have implemented retire.js, and as you can see, I probably don't have time to go through one by one line, but the name is pretty straightforward. We're using the base image as node Alpine, and then we're just installing retire.js, and then we're just running the retire.js against that vulnerable application that we are hosting in our repository. And then that retire.js will produce some sort of output, because the output is really important when we're looking at the tooling, and that output is stored here. And then we would see when this pipeline runs that it will generate its output. Similarly, we're running safety, we're running bandit, we're running truffle hog, and we will show you each tool's output. And you can see, and here we're running nmap, we are scanning this IP address for open ports, and we are storing the output of that as well. And then we are running sslies against my website, and then it will produce some sort of results as well. And the last, we are running OWASP Zap. Here we are pulling a Docker container, and then we are running Zap in a container, and we pass the baseline parameter. So it's only going to run the baseline scan against our website. And then whatever the results of ZAP is will be stored in this output. And as you can see, a keyword here, allow failure underscore is equal to true. That means even if ZAP finds vulnerabilities in this particular stage, it will not fail our build. It will move to the next phase of the pipeline. And once our pipeline is done, I'll just show you. This is how the pipeline would look like. So as you can see, each tooling that is embedded inside each stage, you can have 5 other tools that you want to implement, you know, and this would look exactly how or whatever you have implemented inside each stage. And now, if you want to see what Retire.js found, you can simply click on it. And behind the scenes, you can see all the commands that we passed in the GitLab.yaml file. Those commands are being run on behind the scenes on our GitLab runner. And it is finding vulnerabilities. And then what is artifact? Artifact is the output of the tooling. So here you can see on the right-hand side, that's the output of the tool. We can click download and it will download the artifact. I can just chuck that on my desktop, save that. And I can show you exactly what that artifact sort of looks like. So I've just extracted it. And that's the output of that tool, which is retire.js. So this would highlight, or this would find vulnerabilities like, you know, whatever we are running. If there is any known vulnerability, as you can see, there are a number of vulnerabilities that are medium. I just opened it up in Chrome, but may look better in Notepad++. Similarly, we can go back and we can perhaps look at, say, Nmap. And here you can see I scanned my IP address, and these are the ports that it found are open. And similarly, we've got the artifact. You can directly, we just didn't have enough time to actually showcase that, but you could directly upload the results of these tools in Defect Dozo. So you then can go online and you can have a really nice looking a vulnerability management dashboard where you can see what those vulnerabilities are and what those vulnerabilities actually look like. We can also probably look at ZAP as well. So I'll just show you the output of other tooling. For example, SSLies, we can look at ZAP's output. So here you can see ZAP scanned. We've used the baseline scan, so it's fine. It found like, okay, cookie does not have any HTTP flag set, right? So you can see with this sort of stuff, like see how automated it is. Like with all that 8 or 9 line of code, it's gonna find like some of the, you know, the low-hanging fruit for sure for you. And when you start fixing these things, for example, if you implement HTTP only cookie flag, well, that's going to prevent your cookie being read through a cross-site scripting attack, you know? So you could actually then, you're fixing more things, then the impact of cross-site scripting is reduced, you know? So you can see how DevSecOps is actually helping you. Similarly, if your cookie does not have a secure flag set, that means your cookie can be transmitted over an HTTP protocol. So if you have this set, that means it guarantees that your cookie will only be sent over an HTTPS protocol. And, you know, as you can see, you have like so many benefits. You know, that's the ZAP's baseline scan. Like transport security header is not set and all other stuff that it would find. And then you can tune ZAP's profile to find more advanced issue. You could specify username and password, and you can do an authenticated ZAP scan. So, you know, it's all of those options are available to you. While time permits, I may show you Bandit scan, you know, what that scan. So as you can see, the Bandit is finding vulnerabilities in the Python code at the code level, like it's doing a static code analysis. So Bandit found 3 issues that I can probably show you. So here it says it found an issue starting a process with us. So it found a potential command injection. Then, as a security engineer or whoever is triaging these reports, then they can look at it and go, oh, actually, yes, it is user supplied input being passed to an eval function or something like that, which would lead to code execution. In this case, os.system. And similarly, the next one is it found a hard-coded password. So that is a true positive. So you can see these toolings would help you a lot when in an automated fashion, when it's implemented based on what your requirements are. So yeah, so this is like, probably like a 20,000 foot view of what the DevSecOps pipelines are and what those pipelines look like. We will share our slides. I'm more than happy to provide you the YAML file that we've created, and I think it's probably around 124 lines of code. And yeah, what we just did is we just pulled together all these tools, and these tools are running, yeah, just as desired. Yeah, that's me. Thank you. Any questions? Happy to answer.
Yes, let me